Good evening, fifth graders. Tonight, we are going to be working with adding mixed numbers. We're going to be changing mixed numbers into improper fractions back into mixed numbers, okay? We're also going to be finding common denominators. So please follow along. I'm going to break it down. Hopefully this lesson will help you. We're going to change 3 over 3 into a whole number. So this is when we find out how many of these denominators can go into the numerator. How many 3's can go into 3? Exactly 1. That means this would be 1. We all know that 3 over 3 is 1, but I'm just kind of explaining why it is 1. Next problem here. We're going to change this back into a mixed number. So just like we've seen in the past, we're going to be multiplying these two, and then we're going to add. Multiply, then add. So it's 2 times 2 is 4, plus 1 gives me a 5 over 2. We're keeping that denominator. Now, if I do what I did on the previous slide with 3 over 3, take a look. How many 2's go into 5? Exactly 2. 2's go into 5. What's left over? 1/2. Do you see how it's what we started with? Let's keep looking here. We're going to change this into a mixed number. How many 8's can fit into 13? Exactly 1 8 can fit into 13. What's left over? What couldn't fit into 13? 5 is left over. 8 is my denominator. I'm going to change this back into a improper fraction. Okay? That means improper fraction means my numerator is larger than my denominator. I'm going to have to go 8 times 4, which is 32. I'm going to add this 1, which gives me 33 over 8. Let's check and see if we did it correctly. How many 8's go into 33? Exactly 4, because 4 times 8 is 32. What's left over? 1/8. Just what we started with. Let's change this back into a mixed number. How many 5's go into 17? 3 5's go into 17. 2 is left over, because 3 times 5 is 15. 2 is left over. Let's check and let's reverse it. 3 times 5 is 15, plus 2 is 17. 17 over 5 is exactly where we started. It's getting a little bigger. How many 5's go into 37? 5 times 6 is 30. We can get closer. 5 times 7 is 35. What's left over? I have a 2, and I have a 5 left over with my denominator. Let's check. 5 times 7 is 35, plus 2 is 37 over 5. What's my new mixed number here? How many 5's go into 60? 5 times 10 is 50. 5 times 11 is 55. 5 times 12 is 60. So I have a big 12 out here. What's left over? I have a 2 left over. If I reverse it, 5 times 12 is 60, plus 2 is 62 over 5. What is this as a improper fraction? Multiply, add. 4 times 11 is 44, plus 1 is 45 over 4. If I reverse it, how many 4's go into 45? 11. What's left over? How many 2's go into 3? Exactly 1. What's left over? Half. If I reverse it, take a look. I'm going to multiply, then I'm going to add. 2 times 1 is 2, plus 1 is 3. 3 over 2. Exactly where we started. Now we're going to be adding our mixed numbers. Keep in mind here, let's take a look at this problem here. This is a 5. I'm going to make this 5 a little better here. And this is a 5 as well. Apologize for that. When you're adding, right away we can take these big numbers out. 6 plus 3 is 9. Now let's add the fractions. We have to stack these things. 5 6 equals 3 fifths equals. 6 and 5, common denominators, what do they each go into? They each go into 30. 6 times 5 is 30. 5 times 5 is a 25. 5 times 6 is 30. 3 times 6 is 18. Now I have to add these two fractions up. So what do I have over 30? I'm going to add 25 plus 18 up here to make sure I don't make any errors. 5 plus 8 is 13. 1 plus 2 is 3, plus 1 is 4. So I have 43 over 30. Now, kids, watch. This is why we were doing all that practice earlier with improper fractions into mixed numbers. How many 30s go into 43? 1. What's left over? 13 over 30. Now watch closely. I have to add this to my 9. Does that make sense? Because we can't forget about the 9 up here. So my answer to my original fraction problem would be 9 plus 1, which is a 10, and 13 over 30. It's a lot of steps. The steps are easy, they're simple, but you have to keep everything balanced. Your steps of doing things mentally are out the window. Now you're in Unit 8 in 5th grade. You have got to start showing all of your work. Let's take a look at another problem here. 2.5 plus 4 3/8. Let's watch here. Right away, let's take off these big numbers here. We have a 2 and a 4, these whole numbers, which gives me a 6. I know when I add half plus 3/8, when I add those fractions up, I have to add a 6 to it when I'm done. Let's stack these fractions. Half equals 3/8 equals. The reason why I stack the fractions, kids, is to keep them balanced, or to keep them organized. So when I convert them to equivalent fractions, it's nice and simple. 2 and 8, what do they both go into? Some of you will say 16, which isn't wrong. We just have to reduce more at the end. But 2 can go into 8. So let's put this into 8. The nice thing about into 8 means we can keep that fraction the same. Because times 1 times 1, I'll show you here so you know what I'm talking about, would be the same thing. Here we have to go times 4. Times 4 gives me 4/8. Just like the last problem, we have to add these two fractions up, which gives me 7 over 8. The nice thing here is it's already a fraction. It's not a mixed number. It's not an improper fraction. So I can just add this 7/8 up here to the 6. So my answer is 6 7/8. That's all we have for a review today. Please keep in mind, when you're adding mixed numbers, go ahead and add the whole numbers first. Have that set aside. Then find common denominators with those fractions, like I did with these two examples, and then make sure you add it to that original whole number. Hopefully this helped. Nice short video for tonight. I look forward to working with adding mixed numbers with you tomorrow in class.